welcome all of you to this session. Construction Philosophy is a construction industry magazine which is published from Kochi. We are a year-old magazine published with an intention of disseminating new knowledge and achievements, advancements within the industry. In the past 1 year, we have published about 10 issues focusing on various topics such as sustainable engineering, geotechnical engineering, roads and highways, bridges, viaducts, demolition, value engineering, digitization in construction, etc. Now, as the pandemic has restrained us from usual printing activities, we have started conducting online programs and flash courses for the civil engineering professionals for upscaling their knowledge domain. Well, the purpose of today's session is to deliver an insight about the 7 QS tools for quality administration in the construction industry. Quality, as we all understand, is an end result of countless effort. Every project is a special endeavor and every task desires to be handled differently, although many elements reiterate at each and every range of work. Right from the task planning phase, we ought to continue cautiously and consciously pursue the required tactics for making sure best in every object of work. The coming months are going to be extraordinarily challenging phase as the pandemic has modified the dynamics of our lives and actions. All of us have to be adaptive and inclined to upscale ourselves to cope up with the upcoming states. Today we have with us Engineer Varghese A.Johns, who is the General Manager for Operations and Group Head for Education and Improvement of Dubai Metal Industries Limited. He graduated in Civil Engineering from Motilal Nehru Regional Engineering College, Allahabad, UP, currently known as MNIT, in 1980, and a Fellow in the Institution of Engineers, India, member of American Society of Civil Engineers, ASCE, also registered professional and chartered engineer, India. Mr. Varghese has around 40 years of experience, professional experience in civil and structural design, technical and project management with consultants, EPC companies, structural steel EPC companies in the Middle East and Singapore for oil and gas, industrial, commercial, and residential projects. Working with engineering consultants for Aramco, Saudi, employed by oil and gas companies, ADNOC, Abu Dhabi, and Dolphin Energy, Qatar, and EPC Co. Rotary Engineering Limited, Singapore, as engineering director, working more than 15 years with specialized steel structural engineers and fabricators like Cleveland Bridge, Dubai, Tiger Steel, Sharjah, Hidada Limited, Jeddah, KSA, etc. Currently working as General Manager Operations and Group Head Training and Development with Dubai Metal Industries Limited, Sharjah, UAE, engaged in EPC projects for special steel and architectural structures. Prior to that, with structural consultants, Geostructural Private Limited, Cochin, as Vice President, Technical, associated with Smart City, KMRL, and other projects. On behalf of Construction Philosophy magazine and all the participants, I would like to welcome Engineer Varghese A.Johns to this session. And once again, I apologize for this delay. I welcome all of you to this session. Varghese sir, please.
Good evening, everybody, once again, and sorry for that little delay. Always there is a technical problem, you know. We are all engineers. We can see that the perfection is not always there when you require. So that is where quality comes in. So I like to see yesterday was our Independence Day, 53rd Independence Day, and it was the Engineers Day as well. Hope you must be knowing that the Engineers Day is celebrated on the birthday of our great engineer Vishwesvaraya Padmasri. So this year it is a little bit different than previous years and earlier years, because how much freedom we have this year compared to the previous years. We celebrate independence, but we are still not fully independent. And so that is actually another issue we have to face it as a fraternity or a society or as a person as such. And at the same time, I would like to thank NEBU, the construction philosophy, to organize such a webinar with some subjects which are very relevant to the current situations and scenario. And all of you are again welcome to this webinar, and you all are investing in your future. That is what I can say, because learning is a process that has to continue doing it. And we know that the world is actually not a bad place to live, but even though this pandemic has actually done a lot of damage and changed our matrices of life, everything has got a different angle to it. We don't have that freedom like earlier, 6 months ago. We never thought that a situation would come like this. But still, the Mother Earth is actually giving us a rearranging due to, or maybe using the crisis. It's a crisis for the society as well as the entire world. And smart people, they are trying to convert this crisis into an opportunity. So that is where we all have to be little more, intelligent, or maybe smart enough, how we can convert our crisis, the current pandemic crisis, into an opportunity. Because we know that everything is down, so we need to do more to get less. That is the situation. Before we were doing less and getting more. So how we can achieve the efficiency, the productivity, and the goal to be achieved, because we have to do a lot of work. And to do that, and especially in the engineering fraternity or engineering field, we need to do a hard work and smart work to achieve these goals. Then only I think we can survive in the coming days. So that is why we thought maybe we will start doing some webinars or maybe some topics which are relevant to this present situation, and give some highlight to the people at where we should focus to continue, or maybe to achieve our goals are. Or maybe sometimes it is a survival right now. Maybe the more hard work is required to achieve our goals. So that is why I choose, because I am also doing a similar type of, for our company, developing the entire team to improve the efficiency and productivity, and making a kind of desire for learning. That makes, I always tell them that unless and until you are not a lifelong learner, the learning will never end. You have to keep learning because the format is changed. You have to learn a lot to do your work or achieve your goals in an efficient way. So we have actually collected some tools which are good for quality improvement and techniques. There are so many tools are available right now in the market, or maybe companies are practicing. We choose one of them, that is 7 QC tools, which is mainly practiced in many companies, and they have found results to improve it. Majority of these tools are actually evolved after a crisis like Second World War. After that, companies have realized that this normal conventional style of doing things cannot work. They need to achieve a good efficiency and productivity in their projects as well as services. So they have formulated so many tools. So that is how this, we can say that ISO is one of them. Kaizen, Six Sigma, ZEP, PQM, Balance Scorecard, and so many other things are there. PDCA and things like that. So we have actually chosen one of the tools, which is more or less applicable to projects, manufacturing and services. So the 7 basic tools and processes and service improvement are used to identify and fix issues related to product or processes quality. And in terms of importance, there are the most useful. These are the most useful. Professor Koharu Ishikawa, maybe you must have heard about this professor who was a university professor in Tokyo long time ago, and then he actually developed these 7 QC tools by other quality gurus, and they say that solve 95% of all the problems at workplace can be solved by these 7 QC tools. And quality gurus like Deming and Duran. Deming is WD. Deming is one of the gurus of quality. And then these tools are, as I said, mentioned before, the foundation of Japan's astonishing industrial resurgence after the Second World War. So all these quality systems are actually started with the quality management, TQM. So you must be aware of that, what type of, because I have actually written a couple of 2-3 articles also in CP in the beginning and the earlier issues. Hope you must have read it. That is for the consultants, engineering consultants. So the total quality management, in the sense we can see that what is total means everyone in the organization is involved. So any organization, because you have to have participation of all the individuals, right from top to bottom, has to be involved. That is why it is called the total. The terminology starts with total. The word total means that. Then quality means is a collective action focused on meeting customers' needs. What actually you want to provide to the customer. End of the day, your product or your services are actually being appreciated by the customer. His satisfaction, customer satisfaction is always the quality, because he has to buy it. Whenever you go and buy something, as a customer, your satisfaction is more important, and then you have to assess and evaluate what is actually the quality is. Then management. So the emphasis should be towards continuous improvement, and a quality system is always not standstill. It is a journey. It is not a destination. It will keep going, and it is continuous. And to achieve this, we need to have quality tools. Any organization. So this is how the 7 QC tools comes. The 7 QC tools are actually linked by starting with a flow chart, then cause and effect diagram, that is called as Ishikawa diagram also. Control chart, which is monitor the process for X and Y. This is 2 axes. Prepare a checklist for data collection, because you map the data to process. Then present the data X using a bar graph, because the bar graph is actually showing the intensity of the data, how much, how big and how small, and then rearrange the bars in descending order using Pareto chart. And the last is a scatter plot, which is actually dotted points in an XY graph, which shows that how strong it is actually. So let us look at the definitions of quality, how you define a quality. Sometimes every day we talk about quality for so many reasons. And this is a very common word for everybody. That's a quality, this thing, quality, that thing. But what is it actually? How you define it? So quality is actually, you can define it in so many ways. It's all up to various institutions, various people have actually, scientists, professors, institutions has actually developed according to their purpose or maybe according to their function. So I can say that the most important one is fit for purpose, because we have something which is manufactured, or maybe a services, or maybe a project which is actually constructed or manufactured, which is actually fit for that purpose which is actually manufactured. That is the most important quality definition we can say. Then conformance to requirements. There are certain requirements which you have. If you go and buy certain things, there are some requirements. That is why you buy a product, or maybe you construct. So this has to conform to those requirements for the function that it is designed for. Then freedom from deficiencies, because it cannot have some deficiency so that it will have an impact on the functional attribute of the system. So that cannot be accepted. So it has to be free from all the deficiencies so that it will function better. And quality is a cost. You cannot achieve quality simply just like that. You invest your resources, your money, and all the things which is money and cost. So if you invest more and it's a cost more, and quality is actually demands more resources to obtain or maybe achieve such a product. Then quality is price. Price is actually which consumers willing to pay. You know, you are sometimes you go and buy some certain things, and even if you are you feel that it is expensive, but you will buy it, and you feel that that product will give the value for your money. Then quality is a standard, because when you want to manufacture something or give something, it is actually in between, or maybe product is produced or constructed based on certain established standards so that the quality can be achieved. So quality is also called as a standard. And quality is value for performance. As we said, you know, because the performance is actually important in quality. If a quality product will perform better than any other normal product, because it conforms to so many things, then quality is an experience. Because if you have a certain quality stuff, expensive or this thing, you feel that it is a quality stuff, and you feel there is an experience, you know, because you're using a quality product. So that is how but there are plenty of other definitions for quality, which according to this shortened list of quality, I just put it together here. Then you can define quality also in a quantitative term. That is, Q is equal to P over E, where Q is equal to quality, P is performance, and E is expectations. So the ratio between P over E, that is quality. Actually, it is always said that quality is the ratio between functionalities to cost also. That is another definition. Your performance has to be more than what is your expectations. So if Q is better than or greater than 1, better quality, the customer is satisfied because the performance is better. And Q is less than 1, it's a poor quality because your expectations are more than the performance. And it all depends on P and E are most likely based perception with organization determining performance and the customer determining the expectation. So if I want to buy some things, I have a lot of expectations, but how it is performing, more than what I expected or less than what I expected. So the 7 QC tools helps to the following things, you know, because improve managerial decision-making skills, collect, present, and analyze the data, implement total quality management system, control cost of poor quality, reduce variations and improve quality, because any product can have a lot of variations, you know, in 10 similar products, if you take it, it has got different type of quality. That has to be is a mean variation or mean target you have to achieve. Reduce defects, improve productivity. So defects, how you reduce defect, that is Six Sigma, because that is the elimination of or maybe reducing defect. That is a tool which is called Six Sigma. Maybe you must have heard about it. It's purposely or maybe specifically used for reducing defects in a number of items produced, or maybe in a service, or maybe in a project. And that improves the productivity because it will be faster. Then reduce waste and cycle time, improves efficiency. Waste means waste reduction is elimination of waste is called lean. Lean is a process. Lean is actually a process to eliminate waste. What is a waste? It is when you have a process, it will have lead time and performance actually idle time, because you will have a task which actually carried out. You will not do it continuously. There is break, and you do it, then there is a break. So these are called lead times, which has to be called waste. Or maybe I am waiting for a bus to catch, and 2-3 hours I am just standing there. That is a waste of time. So this is how waste is actually defined in a process. So that improves the efficiency. You will take short time to reach or maybe to complete the process. So application of QC tools in problem solving. So all these tools are to be used for certain applications in problem solving. That is where these tools are mainly recommended for. So this chart actually showing where, because we have seen that not the first one, check sheet, stratification, Pareto diagrams, cause and effect diagram, histograms, scatter diagrams, and control chart. And you want to use certain tool for doing certain things, like identification of a problem, which one I will use it. Defining the problem, which tool I will use it. So this is a chart actually explaining which tool is used for which purpose. So this tool can be looked at in detail so that you can select the particular tool to do your job, or you have to solve your problem, which one has to be adopted or used. So then problem identification and analysis. So you have to first, if you have a problem, you have to identify the problem in detail. Then only you can do the analysis. So which are the tools which will use for identifying your problem? That is data tables, Pareto analysis, cause and effect analysis, trend analysis. These can be used for identifying your problem in a process. So then you use the other one, histograms, scatter diagrams, control chart, also used cause and effect diagrams, trend analysis, that is the chart or maybe scatter diagrams. That is used for analyzing the problem what you have already identified. So the first tool what we have here, this tool is a process flow chart that understand your problem. So the purpose of having a process flow chart is it will give a schematic drawing of process to measure and improve. You all know that in any of your projects or your operations or anywhere you have a process flow chart. You make a flow chart which show the sequence of activities line, and the activities actually defined from a work breakdown structure. So you put it in a sequence like you're making a planning. So then you know that some activities are weak, so that from a physical chart it will give some sort of clue that which one is weak, which one is strong, something like that. Then pictures process as it should be, because it will give an idea whether your process chart is correct, your activities are there, your start to finish, your assumed activities are okay or not okay, so you can have an idea. So the benefits of having a flow chart: identify the process improvement. When you have a process, how it is actually improved by looking at it. So you know that this is actually the right kind of thing. Maybe this is, I didn't miss anything, or maybe I have to add something. Streamline the process. So according to the sequence, you can streamline it, because maybe how many activities, how many tasks you have to include in each activity. That also has to be understood or maybe studied. So reduce cycle time and waste that we have. I have said it before. Waste is actually, if you look at the Lean Six Sigma, there are eight kind of waste. That is actually, maybe later we will do a presentation, or maybe this thing we can talk about that, and the cycle time. Because how long it will take to finish that task, so that the overall period is actually reduced. So you have a productivity time is less compared to losing time in between each task, or maybe some organized way. So understand the process, and people understand how the whole entire projects from start, from finish, how it is actually processed, how it is going, which all other departments are involved. You will have an idea about this process chart. Show duplicated effort and non-value added steps. Sometimes you will know that the activities or tasks are duplicated in your process. So you can avoid that. You can immediately look at it and see that there is a repetition, so you can avoid it. Clarify working relations between people and organization. So there is a relationship also comes from the project team or the task team to the organization. So the working relationship is very important, that maybe it is not identified in the sequence or something. Maybe you will suppose you will not put an activity by HR or what do you call QHSE or something in the process. Okay, it will put maybe HR or other non-value adding overhead departments are not in the stream. Okay, their support is always there, so that you can really look into it and then make it very clear about all these activities. So process flowchart is actually a flowchart. It's a type of diagram that represents a step-by-step activities. Like we said, it's a sequence when help of various kind of box shapes connecting with arrows. You must have seen a lot of process charts which is actually created, box type, step by step, connected with arrows. So that is the purpose, is it gives a visual representation of a process, identify the steps and material needed for the purpose, helps in quickly analyzing the process. So it is like just simply putting a process chart like that. You want to get up early in the morning and you set your alarm. So you can make a process chart based on that. So it is just like giving some sort of a clear, actual, presentable, readable chart. You understand it very well, not by talking it. So it is just like, this is another one. See, look at the symbols used in preparing a flow chart. So like this shapes, start, end, this is an oval shape. Documentation is actually the shape which is shown as a rectangular with one side skewed. Then process is a square or a rectangular. Storage, documentation, or maybe you keep it. Delays have that kind of a symbol. Decision inspection is actually a diamond. Transportation is actually an arrow, big arrow, and flow line is an arrow, simple arrow. So this is how you create a kind of flow chart for your process or your project or something, you know, that big projects, you create all this kind of process flow charts to study and to make it, and you put it on your wall, and what are the activities, what are the tasks in each activities, and how long it will take, whether your process, your sequence is correct, your decisions are correct, or you are mobilizing your resources in which time you need it, what time you need it, when you need it, or what you need it. All those things you can really understand by looking at a flow chart. So that is how it is prepared. So then it comes to the second tool, that is called a cause and effect diagram, that is generally called a Fishbone Diagram by Professor Kawaru Ishikawa. He is actually the professor who was professor in Tokyo University long time ago, and he is one of the gurus of quality, because all these people are actually inspired by development in Japan after the Second World War. You can see that how much they have actually developed in terms of quality in today's time, because everybody likes a Japanese product quality wise, functional wise, and value wise, you know, because that is how it is. All our automobile industry is actually monopolized by them. All other electronic industries monopolized by Japan, you know, because all these companies like Toyota is one of the biggest company which started using 7 QC tools right from the beginning. So here what we do is identify the possible sources of variations, that is X. We will come to the graph later, so you will understand what is X and Y is. Brainstorming and root cause finding technique using Fishbone diagram, because if you want to do a corrective action or maybe a process solution for a problem, you need to do a study which can get you the root cause. Without doing the root cause, you will be doing some quick fix, and the problem will keep on prompting up again and again, you know, because that affect your quality and your product, your customer, and every second day, or maybe somebody buys that brand or a model and it start working for a day and it will stop functioning. So to find out what is actually the root cause of a problem in a process or in a project or maybe in a product, what we use cause and effect diagram. So there are 6 steps that are used in perform a cause and effect diagram. These are simply identify the problem, analyze its technical cause. Step 1, there are technical causes. Then there are brainstorm the team who are actually participating in the product associated with formulation of that particular project or product or services. Draw the problem box and prime arrows, you know, because this is also has got some, the next slides will show how this cause and effect analysis, Fishbone diagram, which is also called. Major categories contributing to the problem. Then a defect, identify a defect cause, because in a whole system, maybe one of the causes is actually giving trouble to all other areas. So you have to identify which one is that. So develop corrective action and perform the analysis. So you have to perform the analysis and then do the corrective action. So unless and until you understand the whole thing, like I said, the root cause analysis is being conducted, carried out, understood the problem, and then you do the corrective action. So this actually looks like this: machine, man, material, method. This is how is one side arrow, and the end result is actually the effect. So this is how, that is why it is called a Fishbone diagram, which is also said. So this is one example that project cost is actually being analyzed using this fishbone diagram or cause and effect diagram. So, okay, as a project manager, if you are going to a site, or maybe you have big problem, small problem related to each department, services, areas, like if you start design, there are so many issues, like revisions are coming, extension of project is coming, there is a variation or a change of scope, non-adequate drawings. So so many issues are actually being identified and plotted on as fishbone diagram like this. Then extension time and delays due to overtime, new codes due to inflation, cost due to inflation, head office controls, and so many things. Extension time and delays are because of these reasons, because that particular area lead or manager can give the input on that area, design can give that input, and then comes to the management. Management is actually bad decisions. We can show poor skills or maybe poor slow reactions, because you present a problem to the management, they don't take it as serious and they give very slow reactions or maybe decisions that also cause this thing. And subcontractors, environment, client, and policy. So there are main causes and sub causes which are actually leading to the main cause, and it's all going to the fishbone main cause leading to a cost problem. So before you start doing a meeting or an analysis of all the problems of a project or a product, you can develop a cause and effect diagram similar to what is actually seen, and then you can identify, sitting with everybody, see that where is actually the problem is, which one is actually holding your project, or maybe costing you more than what you are expected, it is cost overrun. So it is another one, like delay. The projects are delayed because of so many other reasons. This also is another way, because every activity, every process, you can create a cause and effect diagram. Like procurement, you can create a cause and effect diagram, or maybe your quality control, quality assurance and quality control, you can create a cause and effect diagram to control all your activities. So this is something which is good for a management or maybe a senior person to see in overall in one picture, so that he can discuss and take a decision and see that where you have to focus on. So this is how the cause and effect diagram, because the word itself is that causes, and how much effect is actually being impacting on overall process of your system. So that is what it is actually called cause and effect diagram as such. Now we come to the tool number 3, which is control chart. Tool is control chart. Monitor the process for X and Y. This is 2 variables that you will see in X-axis and Y-axis. The purpose of this control chart indicate whether a process is in control or not, because this is something which is standard deviations, which sometimes people, you need to know a little bit of standard deviation and calculation of, that is Six Sigma. I will come to that. The primary purpose of a control chart is to predict expected product outcome. You will know, once you plot the control chart, then you will know it is a stable process is actually happening. Where it is actually gone, the variation is going beyond what is actually beyond the control limit. So you will know that there are some problem because of some reason. You cannot sleep well all the time. You need attention to the process going on, your construction. You need always that you cannot trust the people, because every time it is varying. The process is varying, so that the quality cannot be achieved. So you have to limit your variations within an acceptable zone. benefits, predict process out of control and out specification limits, distinguish between specific and identifiable causes of variation. So this will help to identify the specific and specific between specific and identifiable causes. Because the next slide will explain that more. And then it is a statistical process control, because the quality people can have the ability to perform with getting the information correctly. That is what it will. So when to use a control chart, because what is the applicability and how it is being used, where it is being used. When controlling ongoing process by finding and correcting problem, because a process, like I said, in a manufacturing unit, because there are number of units are manufactured in say 1 hour or 2 hours, and you are in construction, you are pouring concrete, this side, that side, all those sides, but your slump is varying in so many places. Why? The reason is, so you can streamline and see that it is done according to a set standard, so that if it goes beyond it, you know that there is a problem, there is something wrong. When predicting the expected outcome from the process, so within the comfort zone, you can, if it is laying within the comfort zone, you need that the expected outcome is okay. You can predict it, that it is coming all right, as you are in a strong, stable situation. Then determining the process is stable. That is what I was saying. Acceptable limits of variation. Okay, a control chart is actually looks like this. This is called a Shewhart control chart. You have a target that is called a mean chart at the middle, and you have an upper control chart is equal to target plus 3 standard deviation. SD means standard deviation. So you have a lower control limit, which is target minus 3 standard deviation. Because this is only a presentation, because this standard deviation is decided based on the process what you are doing. So that I will show you, the next slide will give you that. Because once you started plotting the results, or maybe your data on a control chart, you have an upper control chart or lower control chart, which is decided by the management, or maybe a specification. And I cannot go beyond this. I cannot have, suppose you are doing in 10 locations concreting, and one place the slump is say 100, okay, it is in the mean. And if it is 110, it is plus. If it is 90, it is minus. So if it is going 60, then you see that it is going outside the acceptable limit. So you should know there is some problem happening. And if you are sitting as an engineer or a administrative manager, this chart will give you an identification or maybe some kind of information that you will be able to take some decision. You will start analyzing why it went wrong. So it will give an idea. So the statistical process control, like normal process variation, you are acceptable. This is within acceptable limit. Special cost variation, special cost is a plus and minus. And see, look at that one place. At one place, it gone outside the permissible limit. So you can study it and see that why it is done. This is what again zone 2Z, zone 3, 1 sigma, 2 sigma. So it is up to you that the zones you create, like what should be your permissible zones limits. You can have 6 sigma there. You don't want 1 sigma or 2 sigma, 3 sigma, because you can have 6 sigma, or maybe you can have 3 sigma. so that it should, all the variation should be within that, so that you are comfortable, because you can assure the quality based on the specification that this should be within that. So that is how it is. Also, all this zone limits are recommended or governed by your specification or your quality norms and quality standards requirements. What is actually established in quality assurance, that will give you this. And then as a quality control, you check against this, a quality control chart. Then you all know that this is the bell mouth standard deviation, this thing. And you calculate, this is how the Six Sigma is actually formed, how you are eliminating defects, how many defects have to be there in a million pieces or maybe million activities, what is the acceptable limit. You can set it to 3 sigma in construction and all, it is very, it is again 99.7%. So you can put it 2 sigma, 95.4, whether it is acceptable or not, is it going to cause a quality issue, it's all up to you to decide it. So that a little bit of standard deviation, you must know these values, what it is given is. Hope you all know a little bit of standard deviation, or maybe people should practice it, the equation, the xi minus x divided by what do you call n, and the whole root is actually the standard deviation, and some equation is there. Actually, you can practice it, and then you can work out this kind of standard deviation, what is required for a particular process. So the fourth tool is data check tally sheet. So you have already collected, prepare the checklist for data collection for X. So you have already collected all the data. This is actually a action taking process, not a recording or data collection process. So this tool is data check or maybe tally sheet. So what is the purpose of this? Data collected can be used for input data for a quality tool. Okay, this data is actually collected from the field or from the activities shop floor, or maybe your construction site, or anywhere what some activity is going on. From there you will collect data, that is the actual. So then you distinguish between facts and opinion. So maybe many people sit in the office and say they have so many opinions about things, but the fact is different. So that is why you collect realistic or maybe the actual data from what it is happening, where it is happening, so that it will give whether your facts are in line with what your opinion is, or it is to be changed. So your process of providing the solution should be based on facts, and then also the figures will also appear beside it. To collect data about the type of problem, defects, rejection, or non-conformance. Maybe you are all aware of that. What is non-conformance is NCR we call in quality system, non-conformity report, because the quality check is actually taken care, conducted, and then there are sheets which developed by the QC engineer or QC personnel, that it is not in conformity with the required quality level. So you will issue a NCR, that is called non-conformity report. So this has to be looked by, normally it is looked by the management also, and see that why this kind of non-conformity is happening, who is responsible for that, what actually went wrong, why he is not attending more seriously attending the problem, or maybe the activities, so that this could result. But I'm not saying that it will never happen. It is always there, but then this quality, then you create, after you have an NCR, you will have a corrective action plan also been prepared and approved or accepted by the quality team or the management, then you do it. So the benefits of doing that, collect data in a systematic and organized manner. Because if you have a particular data sheet kind of thing, you go to the site, if you don't have anything and you just go and look at it, okay, the concrete is under pouring, the reinforcement is put in this way, but you have to document it. This is one of the biggest problems what I have in my whole career. Around 30 plus years I was working abroad. The difference what I found in India and abroad is documentation. People don't document things, because it is a reference for the future. Because all the problems are expected, it can happen. So you can study it and see that what is the root cause. Like we discussed, there is a tool which is used to find out the root cause, so that we can take an action and see it's not the symptoms, it is always the root cause, so that permanently you can eliminate that problem. So for that you need a documented information, and maybe you will have the current work or current project, you will have a sheet, and then maybe since you have done similar projects earlier, you will compare with that what sort of action plans you have taken, why this is happening. You have to highlight what are the root cause. Maybe it will cost money to do something, it may not cost, it may be an error or maybe a negligence of a worker, or maybe a whoever it is actually be doing. So this has to be, that this person has to be trained, or maybe then you call your quality meeting and then you tell them that these are the things happening and why it is happening, so that you can permanently try to eliminate this kind of problem, so that you are looking forward to achieve certain good quality outcomes. Then presence of defects and defectives. So your data sheet will show that what are the defects and what are the defectives items also. It will give a clear clarification or maybe indication that what are the defects actually it is happened at the process, in the process. Facilitate classified data stratification, because you know what is stratification is. Stratification, I have a slide, I will talk after that. Then end of the time we will say that the benefit is ensure quality, parameters against defined work standards to ensure quality. So this is stratification actually. This is a system of forming of layers, classes or categories. Data collected using check sheets may be meaningfully classified is called stratification. Because what is actually happening here? So when to use stratification? Because when come from several sources of conditions such as days of work, suppliers or groups, you will use stratification process or maybe tool. It's also a check sheet which will be looking at, like, this is a very simple thing. I will explain what it is. Like, you have one quality engineer for 3-4 sites. Construction is going on. So you are producing a sheet which is the data coming from all the different locations. So you want to identify that from which location this data come from, which location that come from, so that you can do an assessment or a review. Accordingly, you can make a decision to improve. So this is actually a PDF actually taken from machine 1, machine 2, machine 3, because it doesn't mean that it is machine. It can be 3 different locations of different activities or process, so that you will stratify the information what you got. You will not mix around. If you mix around, your assessment and your study, your action will not work according to what is required. So it's an example what I just put, what is actually the check sheets, what is actually how you do it. This This is actually any kind of process. Okay, this is a manufacturing industry. Some production material is actually been. The chart shows 6 days. Okay, first day of the week 2 or something like that. It is going up to 5 days. This is 5-day what do you call check sheet or data collection. So in that one side you have actually put defects, loose screws or dirt in distance sensor, so many things you can have, and each day how many number of defects you have actually identified, and then note it in a sheet like this. End of the week you are totaling it and you get how many number of inspection you have carried out and what is the percentage of defects you have identified at the end of the week. So that this will give an alarm to how your product is or project or process is in quality. Can you afford to have this many number of defects? No. You will look into the defects which are defect numbers are higher, and you start focusing on and then start investigating why it is happening. So this will give a kind of tool. This is a tool which gives you to make a decision on corrective action, or maybe solving the issues, or maybe understanding why it is actually going wrong. So this is a simple thing. All these tools are not very complicated. It is very simple to implement. This is what people actually very small. What do you call? It's not too much of engineering. Is there? It's logic. More than it is engineering, it is logical approach, smart approach, studies, documentation, so that it will help you to do a correct decision based on the root cause analysis. So now, fifth tool is called histogram. It's a statistical process control technique that I was mentioned earlier. Present the data X using a bar graph. I know that most people, those who are working in the construction industry, you will know that what is a histogram is. Manpower histogram, what do you call equipment histogram, and things like. One side it is number of the quantity, and the other is actually the time, which will know that one you require the maximum number of resources at a particular period of time. So you will study that. So it is a species technique, plotting the shape of a distribution and comparing it with specifications. Allows one to quickly visualize what is going on within a large amount of data. Because it is very difficult sometimes to understand, keep in your mind, in a large, heavy construction is going on, so many activities, 1 million activities happening. So how do you keep everything in? So you have to document it. You have to do some kind of data you collected, and using that data, you create histograms for each area or each processes, what is happening in one project. So the benefits are described: process variations, measure process capability, evaluate spread of the data. So the next slide will show that how you will spread the data in the vertical bars. Present large amount of data. So this is an example which I just wanted to show you, because this is an observation and a data is collected for a temperature variation. It can be a 1 month temperature variation starting from early morning till evening, or maybe a temperature differences showing on a machine, or anywhere. You can have not temperature, you can have any variable activity or things which you observe. So that you want to study it, you can make a kind of data collection like this, because dates, number of observations you will make. If I want to do a temperature observation in the morning from evening, and 10 o'clock I will do a temperature, 12 o'clock I will do, 2 o'clock I will do, 4 o'clock, 6 o'clock, and you will have a different type of temperature is listed in each day. So how these people study, because the predictions are always based on data, studies and assessment. So if you want to study the study, or maybe to make some predictions on what is going to happen, or how you can clearly solve the issues, or maybe you want to recommend something to improve it, or maybe you can take necessary steps because this is like this, so what I should do. Okay, now what it is happened, the temperature is actually varying from 300 to 450 degrees, or maybe Fahrenheit, whatever it is. So then we created a frequency there on the right side, 300 to 315, one frequency, only one data, one type is only found. The other one, 360 to 330, 9 times we found in the entire 1 month study. So like that, you create a frequency also. How many frequency? Like you have 376 to 390, 65 times that variation happened. So that is the biggest frequency there. So based on this frequency, you try to plot a graph. This is the histogram. So from 1, that is 300 to 315, then you come say 375 to 390, that's 65 frequencies I have. So if I am running a machine, okay, I will say that I cannot allow to increase the temperature beyond 345 to 360, maybe say 30. So there is my cutoff. So beyond the temperature is increasing means there is some problem with the machine. Whether what action you need to do, you immediately call the maintenance crew or the manufacturer or the expert, take corrective action. So similarly, like your construction site you are doing, example like what I said, concrete pouring, and you have temperature, I don't know whether big projects, you check the temperature as well of the concrete, or you can say slump. So many times, how many frequencies you have achieved or maybe you observed in the entire process, entire construction, which is beyond the permissible limit, the quality norms. So you will have a study about this, because you are not handling a small project, you are handling a large project with a number of people, number of activities. You need to understand how my quality systems are, quality control, quality assurance and quality control is actually happening. How do we study it? So these are the tools. These are tools which is actually helping you to get the data, put it and study, analyze it, and give suggestions or solve the issues. So immediately there is an alert. The person may be mixing the concrete is not knowing how much water cement ratio has to be followed, so that maybe he's making a mistake, he's not been supervised. So there could be so many reasons you can immediately find out. That is how this histograms are prepared, and histograms, I said before, it is also prepared for your resources allocation. If you want your manpower allocation or collecting manpower, how many manpower in this month, and next month, following months, according to then you prepare a histogram something, and then you know that your resources are limited to certain level. Beyond that resources, how will you manage? Are you going to subcontract it, or you have to hire laborers or people from outside? So you have to have a strategy, a quality management, quality assurance system has to be established. Or maybe your project management technique is actually helping you to manage the project in advance. You will get some idea, next month I need this many people, So what I will do? So you will get an alert based on this kind of chart. That is why this kind of histograms are actually developed. And see, this is another simple example. You are watching a cricket match, Australia versus India, and you must have seen this in the screen, the TV screen, that each over, runs per over, how many runs you are getting per over, how many wickets are fallen, in which run, which over you are having maximum runs, and you are comparing with another team and see that you are making a study and who is better. Your evaluation of making a judgment on the performance and the quality. So this type of histograms used everywhere, because if your activities are done by different people, different locations, different processes you are doing, similar processes, so you can study it, and this will help you to give some kind of indication that who is doing better or how it should be done. All right. Then it comes to the sixth one. The tool is Pareto analysis. Rearrange the bars X in descending order. We have seen that a histogram has got a graph. Now, Pareto analysis is rank comparison of factor related to a quality problem, because this will actually indicate, once you put, when you start using the Pareto analysis, it's a comparison of factor related to quality problems. Then benefit is actually quality improvement, quality teams to identify and focus on critical few factors. Critical few factors. Okay. Now, Pareto analysis actually evolved by Alfredo Pareto, also called 80-20 rule. Maybe I don't know whether you must have heard about this thing, 80-20 rule. Alfredo Pareto, he was actually an economist, Italian economist, lived in 1800s. When he reached Italy and he started after his college and all, if he started living, with a job or something, he found that 20% of the people are holding 80% of the entire country, the land. Maybe that is true in our country as well. The wealth held by 20% is for the entire country. And 80% are poor and 20% hold the entire wealth. So from there onwards, he started working on to find out whether this principle or this is a rule which can be applied in every place. So that he developed this. That is why this 80-20 rule is always there. It is a combination of bar diagram and line graph. Actual frequencies are taken on primary vertical axis, shown by vertical bars in descending order. Percentage cumulative frequencies are taken on secondary vertical axis, shown by line graph in ascending order. It's always been said, what is important is rarely urgent, and what is urgent is rarely important. So that is how we distinguish between which one is urgent, which one is important, and as per which location or which time. So this use of Pareto analysis for prioritizing problems, analyzing symptoms, providing effective solutions. So these are the areas when you have to use Pareto analysis. So this is a typical graph of Pareto analysis or Pareto diagram. So the left side, so you see that we have seen in histogram, we have prepared the bars with different frequencies. So that has to be rearranged in such a way that the maximum will go to one side and then you go ascending order, because the towers the graphs are put it in an ascending order. So, okay, you just put this is one simple example. Count of errors. You can see that the count of errors are on the first three, which is falling within the 20. Okay, these are causes. The three errors, the biggest three errors are caused by three causes. There are three causes as causing 80% of your problem. And the 80% line is actually marked. You can see that it's a travail many. Okay, there are problems also there, but these three causes are creating maximum number of errors. So you will know which area you need to focus on, which are the problems, which are the causes which creating these errors. You know it. So you will start focusing or maximum attention you are giving on these three areas, or the 20%. Maybe there is another bar also will come if you make it an 80% or 20%. This is some kind of a rule which is always working. It has been practiced, then people, and the red one is actually the cumulative errors. You start adding and you will say the vital few, because the first 20 is called the vital few, and the count of errors actually going up to 100% by cumulative plotting. So this is the use of Pareto diagram. Based on a histogram, you can study it and see that which causes are required special attention to solve the issues. So this study will give a kind of alertness, easiness, so that you can pay your attention and see how important. That's why I said how important, how urgent is your important, and how important is your urgency. Because you can select the priority, how you should do it. It depends on the project manager or the one who is running the organization, or maybe running the activity, or maybe the project. So if you can identify which effort get the best results, you can apply your time and focus far more effectively. It is like results you get in 20 and 80%, 20% effort yields 80% of your results. This is the correct slide which is showing in every organization, every process, you will put 20% of effort and you get 80% results. The real life examples are 20% of customers bring 80% of revenue. Isn't it true? In any organization, any company, what you can see, around 20% people are 20% customers, permanent customers bring 80% of the revenue. The rest of the customers are not bringing much value like the 20%. So that is mainly true because you have repeated orders. You are happy with your these customers. You always focus on them. So your attention is always focused on them, but because they bring maximum revenue to the organization. Then 80% of work is completed by 20% of the team. In any organization or any manufacturing or project or anything, there are 20% of the people who really work. And 80% of the work is actually completed by 20% of the team. And the remaining are not contributing as what we have shown in the graph. If you do an analysis, or maybe you collected data in any construction or any facilities, what is doing construction or projects or services, you can see that this rule is actually working. 80% of complaints come from 20% of customers. And you get complaints from people what you have provided some services, project, or maybe your items or anything. And 20% of customers will always bring 80% complaints. And 20% marketing efforts give 80% of results. If you do 20% of good marketing, the effort gives 80% of results. 20% of content drives 80% of traffic. So this is the rule actually established that people found it is working to identify what are how much focus you should give to the productive people and the remaining people. So you can pay the attention. So what are in terms of errors and problems, you have to focus on which areas so that you can have a quality. This can be used as a quality tool to improve your processes or your quality level. So this is how it is Pareto analysis. And then the tool is scatter diagram. Establish the correlation between causes X and effect Y. Because it's a it's a graphical tool, correlates two variables. One is independent on X-axis, one other is dependent on Y-axis. Benefit, it helps and identify and test probable causes. Forecast the future trend based on current relationship between variables. Because this is a diagram which is used to make studies and see that identify where is again the problem is. You will get some sort of indication that it is not strong relationship is not there between the Y and the X-axis. So you will see the graph, you will understand. See, this graph is actually a diagram. Is clear whether the relationship is showing strength of that relationship. A is randomly scattered points, no correlation. There is no correlation between the Y-axis and the X-axis. So that is actually dependent as well as independent axis. Independent is X, dependent is Y. Then B is possible positive correlation. So some sort of a correlation is there. It is coming closer when you plot it. Then the C is strong positive correlation, which is very close. This will go through a mean that I will show you in the next one. So this is how it is actually been identified in positive linear correlation. Y dependent variable, X dependent variable, strong correlation there in the first one. Second is inverse, also negative linear correlation. It can happen, but it is still a correlation strong. And no correlation at all here. Dependent variable, independent variable, and non-linear variable. This is how it is actually been variable based on two activities or maybe two processes. It's very simple to understand in this. Many companies, you know, they have how they will put their benefits or maybe their salaries according to number of years experience and salary. A pattern suggests a positive relationship, because if you put years of experience as one plot and your salary is also going with a strong relationship. But if you see that it is no relation, that is scattered, means there is no basic principle in providing or giving a salary or a benefit to a person based on the experience. You can study it, you can see it, maybe some other reasons. So this will give some sort of an idea whether it is a number of years of experience, which is an independent variable, and then it is a non-independent variable, which is actually the salaries depending on the number of years of experience. So this is how this plot is actually helpful to study it. And second, another example, what I put is speed time, which you are starting from your home and driving to your office. How many minutes it has taken actually. So you plot it for 1 month, and then you put plot against time, minutes or speed. So you get a scattered diagram because you can see that there is a mean line which is supposed to be close relationship between all the things, because one day for some reason you have taken more time, which is not a strong relationship, or maybe something went wrong, but in the meantime you can study and say that I could reach the office by this much time. Which one is that? So that is how actually the study is actually helping scatter diagram. So we have actually gone through all the 7 QC tools. Then I just wanted to say some more slides on how to implement QA/QC. It is phase 1, phase 2, phase 3, and how phase-wise we can do it. And this is something with it's a graph indicating cost versus quality. If you plot it in such a cost, rectifying defects, cost of implementing a quality program, total cost of quality. So you have achieved a point where it is called sometimes sweet spot. So the maximum optimized location of quality versus cost. So you can study it based on how much quality and cost you are spending money and how much you are achieving it or maybe getting it. So this is something which I would like to say that any organization which is working on, it depends on the value creation of the organization. The value is created by a good quality system. It's not only quality system, it is also based on integrity. It is also based on so many other factors, loyalty, trustworthiness of the people, and good, customer satisfaction, things are all. So as an organization, always try to achieve a value creation or create a value for the organization. And money, the revenue is a byproduct of the value you provide. You cannot just work for getting money, but you have to focus on creating value for the organization. It is not only for the organization, the personal level also, because the value is more or less, it is required for any client or any customer. You look at it globally, so many factors involved, whether I am satisfied by the product or services what this company organization is giving, or I constructed a building or designed a building better than somebody else, you are a value added kind of project, then the money will come. So if you start looking for only that, then you don't create a value, it won't be a sustainable kind of development or maybe the value. So I just wanted to show this slide to see that this is what is the focus on doing things. Now this is another slide, I just put it. Transform your construction process with BIM. This is timely detection of classes, better scheduling, planning, cost estimation. BIM offers a host of benefits to the construction industry, assured increased quality resulting profitability, because this is how the modern tools are helping to improve the quality of a process. Because here you are able to identify the problems related to clashes, a better scheduling of the project, scheduling and planning, and cost estimation, because that is 4D, and 5D is scheduling and planning, because the other one is 3D. So this is something which people are, now we are in the process of changing, because I can say that nowadays organizations are hiring skill-based personnel than degree-based, because the degrees and other things are basics, which he cannot produce any kind of assignments or maybe outcome without training. So this is actually transforming their talent models. This is a BIM kind of thing, and digitalizing their talent values. We are actually living in a transformation phase. We cannot, because when I graduated, there was no computer. We all did it manually. We created drawings on manual drafting. Later, after 10 years, the AutoCAD came, and then Start came, and analysis and things like that. There is a process of transformation, because now we live in the fourth industrial revolution. What is intelligence? You know what are the other ones? The first one was steam engine, second was electricity, third was computers, and now fourth is intelligence. So the intelligence is actually the current form of transformation. So we have to focus on using skill-based tools so that it will give better quality, better project management, and help and satisfy the client without much headache. You can sleep well. So the important thing is that your process of learning has to be, the transformation has to be based on skill-based, and you need to learn a lot of skills instead of doing other things. Otherwise, you cannot work. Because I have managed even a lot of people in my departments, because with a lot of qualifications and this thing, but experience is one of the most important, is the best teacher, always we say. And an assignment is done, the better practice of engineering to be learned. So for that, nowadays we need tools. So that is why I just put this. So this is a recap, which I have already discussed. Maybe it is the same thing which already discussed. What is all the 7 tools which are doing. So this is the end of the presentation, and we can open for questions.
Thank you.
If anybody have questions about this.
From Nagashri Gaunkar has asked, are you practicing any tools, any software for TQM?
There are so many softwares available for doing total quality management. But let me tell you something, because every company, organization has a different kind of matrix. Because the software sometimes it cannot absorb, or maybe have the limitation to give you the right kind of, it's a judgment. These are all not very complicated kind of tools. It's not like STAR or something, you put the input and you get the output. You need a lot of experience also practicing or getting a result out of it, about the process, whether it is a project or a manufacturing or anything, like investment and money. When you say project, what is the definition of a project? Is like intelligent investment of, or maybe investment of money in a proper way. That is what a project is. Intelligent effort has to be put to get your output. So that is a project. It has got a start and an end and things like that. But intelligent way, investment is there. This money is involved. So how do you get a better optimization in spending your money? For that, you need this kind of tools to reduce your, like so many tools like Six Sigma. Nowadays, many companies are using Six Sigma. And now it is called Lean Six Sigma. Lean means elimination of waste. Six Sigma means elimination of defects. So combined together, actually, it has been And there are so many courses are offered, green belt, black belt, red belt, and all, you can see in so many computer, many places. It's actually in Dubai and all, many companies are practicing these tools, because it's more or less, when you go to a client, they will definitely ask, what is your quality program? What are the tools you are using? Say, confidence level is increased by telling the client that I am using some proven tools, which is helping me to achieve what you people require as a client. It increased the confidence. So this is why it is being used. So hope people have actually, I don't know how many of you are working in projects, manufacturing, so that this kind of tools are useful. We can use it in projects, all these tools. There are so many other tools as well, not only 7 QC tools, other QC tools also.
Well, there are many questions coming up on the chat box. I would rather, before we go further, can you all please enable your video so that the interactions becomes more effective? Because that is how we do generally. I actually forgot to ask you that before. If you can all please enable your video, it will be more effective. Well, a question from Raghavendra Valmiki. Sir, is there any scope of TQM in BIM application?
Yes, of course. See, that is what I said, in any process, a quality system is required. What is a BIM? BIM is actually a 3-dimensional model created by certain, and then putting the business information model. You need a quality assurance plan to create how you are selecting what sort of details you are preparing, whether it is conforming with a code or a standard practice, or the material what you are using is correct, or the process what you are doing is correct, your presentation of drawing is correct, is it is in line with the required quality required, even the scaling of your detail, whether it is readable, whether that has got information level is sufficient for somebody to execute at site. All these are part of the quality reviews. So what normally they do is, in a BIM, the company has to prepare a quality manual for that. How do we do checking? What kind of checking? What you check on a drawing? So this has to be established with tick boxes, whether it has been done or not, whether it is in compliance with codes or standards, or whether it is in line with the scope of work or not. So all these things are defined in a either sometimes major companies you do its design basis, and you have a quality manual for every type of companies, a process company, manufacturing, or a design company, or a construction company. All these are established. So based on that, you will check. The BIM is only whatever command you will give, it will do it. But what command you will get, how quality command, whether it is required or not, who decides? The person who do it decides. Based on what? Certain limitations, certain specifications, certain practices. All these things. He will not give something which the client doesn't, and it will cost the company, maybe the client doesn't need it. You are doing excess. So that is how it is been. So you have to create some manuals, quality manual for how it's doing. And BIM itself has got a quality manual for doing BIM. That I think you have to ask the BIM specialist what are the quality constraints or maybe literature they can give. But it will not give, as I said, the quality manual is as per based on the project, based on the company, and based on the people and the practices.
Well, anybody has any questions?
Yeah. Hi,
Sir,
hi.
Go ahead, Tibu.
sorry if I can ask you, sir. This firstly, nice presentation.
I just wanted to ask you this question, which was flashed, sir, about the software part, because you know what happens sometimes when you are doing a quality control, you are getting maybe the test results of 7-day, 8-day strengths and other things. When you start feeding in, so you'll automatically get to. I mean, if there is a software, it will be, you know, like we spoke of intelligent kind of.
Maybe
That
I'm an old
interface has
school. I'm an old school thought. Maybe because nowadays every young engineer is depending on a software. So this is a very alarming thing, you know, because what it is actually giving, the result may not be correct because it depends on the input what you give. But where is the sixth sense of judging the results? You must know that if you get what do you call a site, a concrete slump or whatever it is, gradation or something, any kind of information, like I mentioned, you know, you create a data, observation and data created, and then the tools are actually, because these tools are existed before the computer or software has come. People managed to create big project or maybe do big project using these tools, but they used to study it because it's, please don't take me wrong, you don't rely on a computer software, whatever you put it in, like STAD or ETAB or something. I have found so many mistakes, and I have asked the engineer to do it manually and seen the difference. Many times.
Sorry to interrupt, sir. I mean, what I'm actually looking at is when you have various kinds of, let's say in the some values you have. So when you put the values, you automatically get a graph, and that with that graph, you can actually come to a conclusion that, you know, okay, fine, this is where we are going wrong.
Yes,
so,
yes,
so what we are actually, sorry to interrupt, sir, but then what we are looking at is, yes, of course, that human thing is there, but then if these are tools which will, you know, make the job a little more easier. That is what I'm looking at.
Yeah, see, the collection of data you cannot do, computer will not do it. Because you have to first collect the data, and there are softwares which can give you prepare a graph, an X and Y axis, or maybe something it will prepare for you. But the analysis of that result is the engineer's job. That particular small, for me, I don't need a computer. I will just plot an X and Y, and then a few plots based on the X and Y coordinates. I will plot my points. Why do I need a computer? So if you want to sit before the computer, you have to sit before the computer. It will take some time. The software is not work. Within 2 minutes, I can do it this. Because these are tools of that kind. It is not like STAD or anything. Very simple thing, you create templates for this. That is what people do it. Just simple templates, like if you do a, what do you call, Ishikawa diagram, you know, that the root and cause effect, it is like a fishbone diagram. You just make a fishbone diagram and then start calling everybody, and all your team will give you the input. What are the things which are causing or delaying the project or increasing the cost? All these things you can, it's just like giving you some kind of idea, and you get involved with it. See, once you start doing, maybe that is what we are lucky. We have done everything manually in the beginning, and we understand by looking at it what's the problem there. You have to develop that sixth sense of what do you call, assessing the whole thing. So there are softwares. I'm not saying that there are so many softwares, but how much worthy you go for a software for just making a graph? It can give so many softwares, you can use it for that particular portion of effort or work you are doing. But it's nothing to do with QAQC. It's only plotting an XY graph.
So Varghese sir, can I ask a question?
Oh, sure, why not?
See, you are comparing the project manufacturing and products and process
Yes.
are in the same, like when you apply these 7 quality aspects,
Yes.
7 tools.
Yeah.
So is it really workable in the case of, fully workable in the case of a project, that is workable in the case of a product or process?
It works everywhere. See, like if you want to make a flow chart, flow diagram. A flow diagram is actually, you go to a project site, you will see a flow chart. You will have a flow chart for the processes, and you will see a flow chart for your project organization chart. You will see a process, a chart for your procurement chart. Then you will see a chart for quality chart. These all can be applied in a manufacturing also. And
Okay, manufacturing, okay, but in the case of a project, real projects.
yes, project, how do you do that? How you put your project process? Where you start? The start of your project, okay, you have started doing your excavation. You are doing your then pouring concrete or ordering materials, steel. All these things you can put it in a process flow chart. That is what it is based, because it is not a practice back home. That is why the problem is.
Yes.
And then you have the quality chart, because you can see that in every project there is a quality chart and like that all the other tools you can develop for various processes in construction, as well as you can go to the net, Google, and see that how projects charts are made. Because I prepared all this from the Google only, the references and other things, but you can study it very well. And it is applied. See, it is applicable to everywhere, which is a process is happening. A process can be construction, manufacturing, even hospitals. The process, how they do it, and consult a patient. Every kind of activity, there is a process. Each process.
Of course, sir. We can copy almost everything. No. Similar to the products and process, we can try many things in the project, but exactly like products and process, can we 100% copy it in the projects? That is my doubt.
It is not. See, that is what you have to, when you start doing a project management, what are the 5 areas? Like first you do the planning, and the project initiation and project planning, and then execution, monitoring and control, and closeout. These are the 5 elements of a project. So in a project, what you do is, when you do the project management, so you need to understand all the activities. If you want to do a scheduling and planning, you need to do a work breakdown structure. You know what is a work breakdown?
Yes, we do it.
Yes. So if you do it, and work breakdown structure is actually defining the task and the duration, how long it will take, and then how much money it requires to do that. So this is a process. So how this is up to you. You have to identify the task in a particular activity. What is the task? How long it will take? How much it will cost? These are the 3 things you as a project manager, you need to know. So this can be put in a process system, otherwise how will you study it?
Yes, sir. You mentioned about the slum and the histogram. In a project, we are, while doing concreting, we do measure the slum.
Yeah.
At the same day, you mentioned about linking it with the histogram.
Yeah, histogram is actually the product of the data you collected.
Yes.
See, that's what I'm saying. Maybe the quality engineer of a company has 10 sites. Let me say, 10 sites are there.
Okay.
So he will get this data from 10 different, because in one place the the concrete is, the slump is 90 mm, another place is 100 mm, 110 mm. So you will get different data. That is what stratification also, you collect it and then you put this graph, make a frequency and then make a graph and you will study it. It is very difficult for one quality engineer to study 10 sites in memory. He cannot make a suggestion or a solution, and he cannot identify where the problem is. This is a study and identification. So then immediately he will take necessary corrective action. Why this is happening in one particular site, the slump is always lower. So there is a problem, maybe he's adding more water or something, you know.
Yes.
So how do we identify the problem? This is very important. Unless and until you don't identify it, you cannot give a solution for it. So if you have a various number of sites, this kind of tools will give you, and this is a document, which is a reference. You will keep it in the file saying that this is what happened and you have done this corrective action. And then you call the people involved and give a little bit of lecture and saying that why this has happened, this is the reason, so don't repeat it. So you can do a complete correction there. This is what quality means. You improve the quality there.
Okay, sir.
I think that 7 tools. Sorry, I think the 7 tools which sir was telling, we don't have to implement everything. We can choose which one is relevant. Like for the quality, the technician guy, sir was telling about the quality technician, the slum taking technician or the concrete pouring case. That guy only has to take care of the standard deviation values. For example, he has to maintain the standard deviation, upper limit, lower limit, and median limit.
Yes.
He has the technician or the crew has to maintain that data only.
That's right.
When we talk about the project management in terms of planning, that they have to talk about the cause and effect diagram. He has to consider, the team has to go. So
yes,
that's a project management tool. It's called a project management. How each department can implement. Like the planning guy has to implement his way of quality management tools. The implementation guy has to manage his way of implementation tool. The checklist which is following, maybe the checklist is followed by the client consultant guys. So they will insist to have a inspection records or WR or NCRs. So this sort of things. So it's a different aspects. You don't have to follow everything. This is why implementing.
Some of them are interlinked.
Yeah.
So that you have to do is like a project chart is actually independent from all others, but you normally do it for every project. A project organization chart, quality chart.
Yeah.
You know what the activities you are going through, which person is doing. Then you're doing a data collection. These data are used to do some kind of assessment or study.
Yeah.
So you need all the areas related to your process. Because at a project, so many processes are there.
Yeah.
So a project manager requires all this.
Correct. But the challenge exists in the data feeding. Challenge always exists in the data feeding.
That's what actually I want to make a small clarification, a little clarification, because Himanshu was not pretty happy with that, Himanshu, basically, engineer Varghese Jones was not trying to say that there is no software available. There are software available, but actually what the point that he was trying to make is we should be able to figure it out manually all the time. Because the new generation, as he has mentioned, actually that's a big disaster that we have been seeing from a couple of years. The new generation is always looking for a software to make their work easy. And what they see, if you look at even the START program, yesterday we had a discussion actually with regards to design. I had a discussion with Varghese sir, and he was actually mentioning the same thing. He had asked somebody to recheck manually a design that they have prepared in STAD or ETAD, and there was huge differences. So we should be able to identify, and we should have that instinct to identify a certain if there is any problem. That is what actually he was trying to make. That was the point that he was trying to make. Even last time when we had a session, engineer Suri Prakash also had mentioned the same thing. You remember, I hope. even though you are very good in ETAB or Stat Pro, you should be able to do it manually. Every time you should take a calculator and check it manually. So that is what actually he was trying to make. That was the point that he was trying to make.
See, every
nothing like that. Point, sir. Sorry, sir. Only thing is, when my only point was, yes, I do fully agree that whatever is the thing we have to physically do it, and I do give full regard to your experience. But then I have one thing to say that that gut feeling oblique the instinct of taking a decision comes with a lot of experience, and with these kind of tools. They may, if like as if the project is for 5 to 6 years, if you have to roll back maybe 2 years, what were the things and what was the profile of things, maybe you would have changed the queries where you're getting the aggregate from, and XYZ, there can be XYZ. At that point in time, if you have soft data with you, it is easy to compare. That is my entire point of this thing. Otherwise, I'm fully with you that that physically doing and checking things is very important. Thanks.
That is why I said every activity, when you do it, you should have a proper documentation. So this document is actually helping you to make a decision in the future. A similar thing happens, so this will help. So once you have actually corrected a mistake, that is, the team is actually knowing that this is a mistake and it is corrected, they should follow the similar pattern, the corrected way. So that is what is actually we are trying, that is quality. We are improving, continuously doing this. This process is not limited and it is a continuous process. Quality is not stopping anywhere. It is a continuous process that you have to keep vigilant. And see, maybe a good driver who is driving for the last 25 years, he will make maybe today an accident. So even with your experience, because something can go wrong sometimes, how will you rectify why it is there? So it is the human element is there. The human error is always come that way. So to avoid that, we knowingly see. Let me tell you, all these tools and quality system has actually evolved to avoid this human error, human element, which you are not 100%.
So human error plus, there is a lot of variation from region to region. For example, if I am doing a project in Maharashtra, it is quite different from a project in Gujarat or in Chennai, saying that the locally available ingredients vary a lot. So you need to have that SOP set up. Once you have the SOP set up, you will have a correct mix design and then go in for the correct concrete. Like Dr. Varghese said, your various slumps are also dependent on the moisture content of each ingredient. So you need to have an SOP and have certain formats.
Yeah. Each location says what I am doing here in Dubai won't be applicable to India, because that is, so as you said, that is the right way. You establish a certain SOP. That is what I showed that chart, because you will establish your zones, whether it is 1 sigma, 2 sigma, you establish that and you see the variation not going beyond outside it. So it is, see, this is the judgment what the engineer has to come with. It is not like just I have this thing and I have an SOP and that's it. No, it doesn't work like that.
Yes.
You need to have a localized or maybe case-to-case study and understanding of items. That is why an engineer is required. That is the role of the engineer. And if there is any variations you see, please document it. That is what we do in this part of the world. Everything what you find something wrong, something good, you will document it. So
Varghese sir, about quality circles in TQM.
Yes.
I heard many times regarding this. In NDPC, they have successfully done it.
Yes.
In India.
So
can you just compare it with our projects. I am finding difficulty to compare this with our actual construction projects.
Yes, quality circle is actually a part of quality TQM, which we are actually maybe next week that is included in that part, because quality cycle. So it is not one word. There is 3-4 slides I have only prepared about quality cycle, how it should be done, what is the benefit, and how it is implemented. Or it's actually a group of people.
Yes,
Quality
sir,
circle is actually constituting a group of people, not so many, 1 or 2, 3 people. Every week they meet together and see their problems, and management has to come in there, support them, and give the required level of required solutions, or maybe help solve the problem.
In that case, I think, sir, different projects
Yes.
at different locations under a senior project manager can exercise these quality circles.
The quality circle is actually done by the lower level people, not the manager.
No. Under him, the supervisor categories of different sites can make a quality circle.
Yes, that is how a quality circle is made. Yes.
Okay.
And then the problem here it is, you have to make a template. What is your scope in quality circle? What you will do? What you will check? Why you will identify things? You have to have some kind of a documentation based on a template. So
yes,
that is actually the job of the line manager or the senior engineer, or who is experienced, or maybe the QC, because QC won't be knowing every aspect of a project. They are working with ITP, they have an inspection test plan. They will say, okay, they tick boxes. This is what they do. But the real line manager of the section, the process, has to understand this, what is actually to be done. And it requires the scope, understanding of the scope, the standards, codes, and the quality of the people, those who are executing that, also needs to be looked at, whether they are capable of doing, they are qualified enough, or they experienced enough, so that they can be given the task, so that you can depend on them. So, but they have to be in the quality circle.
Yes, sir. Thank you.
Well, thank you so much. The discussion can go on for many hours. Our discussions are becoming more and more productive. I'm so happy to see more and more professionals coming in, like new faces. I'm seeing here, Mr. Chandresh, and Mr. Manoj Khare, Manoj C. George, Devasya VP, Mrs. Arundhati D. A lot of them, other than our regular, faces. So happy to see you all. We'll have more and more sessions like this. Next Wednesday also we'll be having another session based on the same theme, like quality management.
That will be quality assurance versus quality control and its application.
Yeah, we wanted to give a presentation on that as well. Actually, that initial, the presentation on that as well. But since we are running short of time, because today we had a difficult time with the network. Varghese sir was not able to log in, due to some network issues, and it took us, about 20 minutes to fix it. But next time we'll make sure that that doesn't happen, So we can start at 7:30 itself sharp, so that we can spend at least 1.5 to 1 hour 45 minutes, and the discussion part. And what I'm actually seeing is every time a lot of them, they leave the session after some time, but always the best part is at the end. So we all have to realize that the best part is always towards the end, So anyway, thanks. Thank you so much, everyone. Anybody has we can spend 1 or 2 minutes, if you anybody have any concern.
Anything on precast? We were to start the precast, that small thing.
Yeah, we are actually working on that. Actually, Varghese sir is also with me working on that. basically the problem, the delay is to get consents from the concerned companies, because we
Okay.
want to combine precast and what is that, sir? Composite structures. So we are
Okay.
looking forward to combine, combining both of both those topics, so
It's
that
Yeah.
it can be.
It's basically three things. One is composite and steel and modular. Because
Okay.
this is actually the future. All over rest of the world, people are not very much doing the conventional concrete type of building. They have changed from concrete to composite, and then or maybe steel and modular. The reason is basically in our country or maybe our state especially, the non-availability of raw materials. Aggregates are not available. This we need to reduce. Like if I say that I have to cast a column of 1 meter by 1 meter, a composite can come down to 55 by 55. So this is the reduction what, and then a 30% of total overall weight of the structure is reduced. So your foundations, your piles, your pile cap, everything is reduced. And a lot of things are actually happened in the shop. So you fabricate and bring it, and your labor requirement at site is maybe 50%. And your time required to install and do the things maybe 60% of a concrete building.
And quality is 100% more.
Yeah,
Yes.
because you are doing the quality in the sense most of the steel structures are fabricated in a controlled situation in a factory.
Yes, yes.
So you can assure the quality better there.
Better.
There is no
We'll be
cutting.
we'll be having a flash course on these two topics actually combined.
Great.
And basically, Mr. Chandresh will definitely form. We have a WhatsApp group actually.
Okay.
I'll add you guys also in that, so
Thanks,
that you will get updates on whatever topics we are going to come up with. And basically, I have messaged my number to you. You can also save that number. I'll be sending individual messages to everyone, so that you all can save my number also, so that you all will get broadcasted messages also. So Himanshu will be coming soon with the topic. Give me some time.
When is it tentatively going to be held? Because
Probably by end of this month.
Okay.
We have kept this time actually 7:30 to 9 for this exclusive sessions, because everybody can attend.
Actually, at least in a week, 3 or 4 webinars I am doing. For my company also I am doing every week. And this is actually the quality part is 2-3 sessions. This is QAQC, and then the other one is continuous versus continual versus rapid improvements. That is, these 3 are related to quality. Because once you complete all these 3 sessions, you will have some idea how it is interlinked. This is like what is quality circle is in the other one. It is there already. So that will be done with the other quality versus this thing. It is there already.
Well, next time actually when I broadcast a program, please, all of you, please share it to your friends also. Our intention is to bring in more and more professionals to this forum, so that we can all work towards a single goal. See, our motive is quality. So let us all work towards it. So let us bring in more and more people.
We have suffered because of non-quality, because if you see in Cochin, there is a bridge is constructed, Palarivattam, it is lying. The 100% flow is in the quality systems. This kind of loss of money and time and facilities are happening because of not paying attention or priority to quality systems.
Sir,
so we are actually...
Another biggest problem is the quality of RMC that is available for projects. Now I'll just give you my personal experience in 1 second. The amount of money that we waste on waterproofing because of poor RMC available in the market is astounding. It's astounding, and it really bleeds the developers and the project managers all together, because to maintain the quality of the structure, you need to spend a lot on waterproofing nowadays.
So that is what, see, the conventional type of systems are obsolete in any part of the world. So if you go to Japan or Hong Kong, they don't even make steel structure or composite. They make modular structures for
Yes,
high-rise buildings.
yes,
Each apartment is actually made as a modular system. They bring it and fit it and then do the interior.
correct.
So this is what fast construction. See, recently the Wuhan, they have constructed the 1,000 bed hospital in 30 days or 40, what do you call, 25 days. How this is possible?
Yeah,
Because if you start a project conventional, it will take 2, 3 years, 4 years, something, and we don't know. Materials are not available, aggregate is not available, labor is not available. So why do we put our neck in such a situation and then suffer?
no, mostly it's the mindset of the consumers also.
So that is,
In
yeah,
commercial sector, if you are building a residential condominium or if you are building a commercial building, you would not like to do a precast elements into it because it's not easily accepted by the consumer. So there you need to have a brick and mortar structure, and you see the RCC framework, and then do all the filler walls, and then go ahead with the facade work and all that. So that's the process that is unfortunately being followed in India.
no, I am attending SCS webinars happening every 2 weeks. You know, the steel construction, what do you call? I always attend that. There are so many composite and steel structures are being done in India now. Plenty of it. So many I can list out. If you go to their site, you can see that. And composite, precast, everything. And it is changing. That is what the transformation is taking place because we are compelled to do it. Scarcity of materials, scarcity of labor, things like that. Money,
time, quality, yeah.
quality.
We have to switch to some kind of technologies like that. We have to the methodologies have to change. Maybe in the coming quarters we'll witness all this.
This maybe later we will have a kind of drive meeting all the developers or government agencies and things like that and make them convinced that we can improve things, not by, because there is a lot of other angle on it, the commercial angle and the corruption angle and things like, because all this actually bind together and not giving a free way to go in a better, faster way. That is what is holding actually.
Yes.
So
In
we
fact,
are suffering. The public is suffering. The public money is being utilized making bridges. And where we stand, we will look at the Palarivattam bridge. It is a disaster. And you go and you just click on bridges in China. The way the bridges and other things are, infrastructure is made. Can you imagine it? Impossible to see how these people are doing it. World is going so fast, and then we are pushed behind in such a place that we are still limping to come.
Very true, very true.
So anyway, hope because the drive, we are actually started doing this drive, making the awareness of how things can be done better. Quality is one of the biggest problems we face in India, especially in Kerala. So the awareness has to be there. There is no commitment or no priority is given to that. If I go for a meeting with a client, the first thing they ask, quality, QAQC procedure and HSE procedure.
How much is it?
Two different documents they want.
How much
it cost? Yes.
Yes.
Yeah.
I had a difficult time to convince one of the companies, a very reputed company in Bombay, to set up a laboratory for testing, for doing the sieve analysis, for having a design mix. So we were getting RMC supply from Godrej and various other Ultratech and all those RMC suppliers, but they did not want to set up a on-site laboratory. So when the chairman asked me how much does it cost, I said just 20 lakhs. Oh, is that only that's a very small amount? You can go ahead. So if I had said 50 lakhs, he would not have allowed, I'm sure.
No, but basically there is a lot of, it is more than that, there are vested interests in doing all these things. That is what it is pulling down in many areas, we can see if you go to the government agencies, they're not very,
yeah, they are not.
From their heart, they don't want to do it. They don't want to be exposed.
Sir, road work, how road work is suffering. All the roads, infrastructure roads are in shambles.
Potholes. So anyway, this is somewhere we have to start, because otherwise there is no way we can go ahead. Because at least for our next generation should have some better infrastructure than our, because that initiative has to be taken now. It will take some time. It is delayed, but
in fact, the intent of construction philosophy is that actually these are the concerns that we had.
I was there when it was launched, and then I moved to Dubai. That I couldn't.
Yeah. We had a long discussion with people like Varghese A.Johns.FIE, Surya Prakash, a lot of professionals, right from Delhi to Kerala. We had long discussions before we launched the magazine. And the contents, everything were formulated based on their feedbacks, the feedbacks from people like them. And gradually, eventually, we have to make it a platform for all the engineers to meet. Basically, as like the architects have, they have larger platforms. So we also must have a larger platform wherein we can all discuss about various aspects, various advancements, achievements, various methodologies, processes. We should be able to discuss on a single platform. That is our intent. The name itself is shows that construction philosophy. It sounds really strange. This is where there is no philosophy, but we want to bring in a philosophy, a way of doing things. So well, it is time to wind up now. It's already 10 o'clock. So I'll see you next time. We'll come up with other interesting topics very soon. Thank you so much. Thank you all the participants. See you soon. Good night to all.
Thank you.